Yes, hello. I'm going to try to cover a little bit of chapter 10 in this video. 10.1. 10.1 and 10.2, I usually teach them at the same time or together because this is really the same thing. It just builds upon this rule, but the nth root, this is called an index. Sorry, let me make sure I have the right pen. This here is called an index. And here's your exponent, of course. And the rule is that the nth root of a to the n is simply a. So if it says find the square root, yes, you can use your calculator. It's just when we start using variables, you need to know this rule. So right now, if you didn't have a calculator, you might take that 324 apart and split it up into things. I need to make that pen normal. My son was playing with it. Let me use a dark blue and no effects. Hopefully that'll work. But 324 isn't necessarily the easiest. You know, if you take make a tree out of this like you would in basic algebra or basic math, really. But what you'll do is you'll figure out that it's really 18 times 18. So it's really the square root of 18 squared. Well, then, since the rule is the nth root of a to the n is a, you simply bring that 18 out. And I'm not going to spend time right now on absolute value because in the next one, your computer in this section will always say, assume that all variables under the radicals represent non-negative numbers, because you can't have an even root and a negative number underneath. That makes it an imaginary number, which we will cover later in this chapter. So, but we're just going to, for the sake of this whole lesson, we're going to say that the variables all represent non-negative numbers, okay? So the next one says simplify by factoring. What they really mean is 49 is 7 times 7, you know? Or you can call it 7 squared. You know this is basic math. So what they want from you is to represent this with a radical. Oh, and your index, you know, just so you know, if you don't know this, you know this is called a square root, but your index, when you don't see it, it's actually an implied 2. Like this up here was really a 2. We just don't write it there because it's an implied 2. Okay, so the next one, you could write the 49 as a 7 squared, you see? And then you really, could you write the x to the 6 as something squared? Because your goal is to bring everything underneath out cleanly. So you could say, well, I need a 2 here because then I can apply that rule. You know, it's the same thing for the nth root of a to the n, b to the n. You know, you can have an unlimited amount of different pieces underneath that radical, but anything that has an exponent that matches the index will come out. So the a would come out and then the b would come out. Well, that's what you're trying to create. You want this piece and that piece to match the index. That's what you want. So you're going to create that. So ask yourself, if you have some knowledge from chapter 5, so if you're in a 112 class, you might have to go back and review that because my 110 folks, they learned this already in class. But we know the rule. Let me put it over here. I'm making a mess. That's okay. If I told you to apply this rule back in chapter 5, you would have said, oh, when I have a power to a power, I multiply, and this really makes an x to the 6. Now you're going to kind of do this in a reverse, kind of, and you want to create that 2. So what goes inside? Well, an x cubed, and you can check your work. You should be able to move back from this to the original. So 7 squared is 49 true, and x cubed squared is x to the 6 true. You see, but now you have an index that, or the exponent that matches your index. So this 7 comes out, and then the x cubed comes out. And that is now simplified. That's all it is. So this is not terrible. You want to pay attention to detail. We're going to do some negative exponents here a little bit. I don't know if we have enough time right now. I'm making these short. Hopefully I'm actually recording. For real, I've done that. I am recording. Okay, we're okay. So find the cube root. And yes, we decided to mainly focus on square roots, but some of these are not terrible, so I wanted to go ahead and keep them in the lesson and cover them. Find the cube root. So there is, you're going to learn this. See, and this is the problem with chapter 10. There are so many little rules, but I like to apply this one first, actually. In this case, what I'm saying is, if there's a fraction underneath the radical, you could technically split it up and the numerator and the denominator both get that same radical. So I would prefer that on this, in this specific case. You could do it differently. They haven't taught you this yet, or I haven't actually, you know, so this is where I struggle a little, and I admitted in class the same, that I like to use this rule that's in the future. But at the same time, I'm going to show you two ways to do this, and then you're going to decide which one you like better, okay? So, so we could write it like this. The cube root of negative 1/7 cubed, because if you go back to the basics, when you had, and I'm going to work down here for a second, when you had, if you wanted to test it, if you had an a over b to the n, it's a to the n over b to the n. And all I mean by that is it's like this. You can check this. -1 cubed is -1 times -1 times -1, which is -1. And 7 cubed is 7 times 7 times 7, which is 343. So if you do it this way, then that whole piece is taken to the third power and gives you back to your original. And then you have an index that matches your exponent, and then this piece that's inside the parentheses here simply comes out, and this is the way it was simplified, okay? Or, so this is where you can dislike me greatly, because I'm going to give you some options. You're like, oh, I really like that, and this one doesn't make sense to me, and she's bothering me with both views. I can't help that. It is the nature of this material. So you could also say, I'm going to use this rule up here because I like that better. And then I'm going to split that up and say, oh, I have a cube root of -1 over a cube root of 343. Only one of them is negative. You can put it wherever you want, really, but we prefer the numerator. And then you say, well, what is the cube root of -1 could be written as, and I know it's a little weird with the ones. -1 times -1 times -1 is -1. And then we have a cubed root of 7 cubed. And then you can say, oh, out of this one, the -1 comes out. And out of this one, the 7 comes out. And do you see how either way you do this, whether you split it up, numerator, denominator or not, it'll give you the same result. I know I go kind of painfully slowly on some of these, but I want to make sure you understand you have options. It just, you need to understand one way or the other and make it happen. And it depends on the problem, which way is easier a lot of times. Okay, so let me see if I can get rid of all this stuff. Okay, so then here, I'm going to try to do everything 10-1 real quick, but I might not be able to deliver on that because my son's show is over. Okay, find the cube root. So cube root of, and you could rewrite this. Oh, we did one like this already. -2 cubed, -2 times -2 times -2. And then you need a 3 as an exponent outside this time though. So this is a little different than the last one. So you want this to be a 3. And then you say, well, what would the inside have to be? and it's an x squared because 2 times 3 is 6. And I hope this makes sense to you. Your goal is to make the exponent inside match. And then whatever that thing in the parentheses is comes out. That's your final answer. Now simplify this one here. It says simplify if an expression does not represent a real number, state so. So the just so you know, if your index is even, the radicand is what it's called, meaning the thing under the root, that's your radicand in this case, this piece, right, negative 625. If your index is even, the radicand can't be negative, or if it is negative, it's not going to be a real number. So we have to be careful here. So if index is even, if the radicand is negative, you just, at this point, you would just say it's not real. Later, you will deal with those, and 10.7 will actually do imaginary numbers and complex numbers, but in this, right now, we're just going to say it's not real. So this has to be even now. You see how on the odd one, it was not a problem. Why is that not a problem? Because -2 times -2 times -2 truly is a -8. But nothing multiplied times itself an even amount of times could ever give you a negative. So that's why, okay? So I do like to explain it so that you understand what's going on actually, hopefully. Okay, now find the root. So now it's getting a little different because we have some indices, but you can still do this the same way as you did the last one. There's another thing you can do with the rational exponents, but actually you have everything you need to do this right now. You have a 2 to the 4th, and then you need a 4, because your index is a 4. What has to be inside? X squared. 2 times 4 is 8, true. What comes out? 2. What comes out? X squared. And then sometimes we have something that stays under. So this one is clean. Yep, I'm not going to cover that one then. It's pretty much the same. This one is pretty much the same. They're all evenly divisible. I'm looking for something more complicated. Oh, maybe it's happening later. It will happen in the, but I'm not sure exactly where in the lesson. That's okay. So this one is just a square root. So what you're going to do is you're going to put a radical. You're going to create things underneath that have an exponent of 2. Whatever that thing is in the parentheses, you know, so just the square root of b to the 42nd, you could rewrite that as a square root of something squared. What is that something? B to the 21. 21 times 2 is 42. What comes out? The b to the 21. You see? That's just the b part. I'm not going to do them all because I'm repeating myself here. And what I'll do is if you want to work those with me in the Zoom session, you will let me know and I'll work with you. Those are all evenly divisible, so I don't even want to do that either. These ones too, you can rewrite them as something to the 4th, you see? B to the 12th could be rewritten as what? B cubed to the 4th. 3 times 4 is 12. So I'll do one more, but yes, very repetitive. A lot of this is because the homework is repetitive. Why is it repetitive? So that you really get good at it. Okay, so this one here, I need something to the 5th power. I'm not going to say this isn't real because this is an odd index, so I don't worry about a negative. This is completely doable. You could have -2 times itself 5 times, and you're going to get a -32 true. X, I need a 15 total. I need a 5 here. What has to be inside? You see, so I go ahead and write the parentheses. I put what I need there, and then I think about what has to be here to make that true. 15. I have to put a 3. I have no choice. And then I say I have some Y's. I need for that to be a 5. Well, what's inside? Just simply a Y in this case. What comes out? A -2. What comes out? An X cubed. What comes out? A Y. Now, at some point, we're going to have some where stuff is left under. I wish it was happening already. It's not happening though. I'm going to go ahead and cover this just in case. So I'm going to write the same problem, or, well, something very similar. Where am I? For the sake of time, let me hold off. I'll just cover what you need for this homework. Sorry, I change my mind at times. Okay, simplify the radical. This here, certainly, I would like to go ahead and split it. You could do this two ways. And again, this is one of those ones you could do two ways. I need for this to have what out here? I need the 2, because then the 2 and that index, and then this piece comes out. So then I can apply that rule, nth root of a to the n is a. And then you could say, well, what would have to be in here? X to the third, 3 times 2 is 6, true. What would have to be here? What squared is 64, right? And what squared? So this is one way to do it. Double check your work as you go. And then you would say, oh, that's what comes out, x cubed over 8y. Because the exponent matched the index, that's a y. And again, this is where I prefer to use the quotient rule first, which I might not teach till later, but you can, when you have a nth root of a over b, you can split it up and rewrite it like this. It's just personal preference in this case. Sometimes it really helps you to split them or to put them under together. In this case, it really is just personal preference. I'm going to put x cubed. You see, I just feel more comfortable personally to split them up, but there's nothing wrong with either way. 8 squared is 64, true. Y squared is y squared. And then you would say, okay, this index matches that, so the x cubed comes out. This index matches that, so the 8 comes out, and then the y comes out. Do you see? It doesn't matter at all. Now, this one here, if f of x is the square root of 10x plus 13, find f of 0. What is this thing? This is a function notation. But what did we learn before? If it wants you to just find something, don't you just plug it in? So wouldn't you just say f of 0 equals the square root of wherever you see an x, you put a 0. So don't make these worse than they are. F of 0 is 10 times 0 is 0 is 0 plus 13. So this is a final answer. Sometimes something here will clean up and it will simplify. So like on the next one, g of x is the cubed root of x minus 5. These graphs are cool, but we don't have time to do graphs right now, but that's okay. I like the square root graphs too, but it's okay. The nature of this semester is that we're going to remove some of the non-essential. Okay, x. So g of -3, what they're telling you is wherever there was an x in the original here, you're going to put a -3, -3 minus 5, which then turns into, and I don't like using equal signs as far as creating some equation that wasn't there, cube root of -8, which is the cube root of -2 cubed, which the -2 comes out. So what does this mean? G of -3 equals -2. What this means is when you plug in a -3 for x, then you get a -2 out for the y, if you were graphing this. Where is 10.2? I'm trying to get 10.1 done. Oh, excuse me while I'm making you dizzy. This can't all be 10.1, can it? No. Okay, sorry, I wrote somewhere where 10.2 starts. There it is. So how about I make a new video over 10.2. Thank you for coming, and I will make another one. Short is good.